Hey guys, hope you're all doing good and welcome to our new course on basics of electric vehicle simulation part 4. As always, pay attention to the learning aids that occurs throughout the course. It helps you understand the topics that you need to really remember and topics that are not included in this particular course. Now, what will you gain from this short course? So the first and the most important thing that you will be gain out of this course is to understand the importance of aerodynamics. You will be able to understand the quantitative parameters that aerodynamists look at, which are typically called as drag and lift. So you might have encountered terminologies like drag coefficient, lift coefficient, or drag force and lift force. You will be able to understand these terminologies and how these terminologies come into existence. And then finally, towards the end of the course, you will be able to perform virtual wind tunnel tests using Ansys Fluent. Now, who will benefit from this course? If you are an undergraduate student who has never done aerodynamics, you will gain a lot of value from this particular course because this course also teaches you the fundamentals of fluid mechanics, and hopefully when we teach fluid mechanics and aerodynamics together, you are more motivated to concentrate on the theoretical parts of fluid mechanics. Now, if you're a graduate student who is venturing into the EV domain or automotive domain and you want to learn about aerodynamics, then this course is going to be marginally helpful for you, because if you are a graduate student, chances are that you are already quite comfortable with fluid mechanics, and hence the theoretical concepts that we cover in the short course might not be that fulfilling for you. But if you're interested in quickly learning how to do a CFD simulation for aerodynamics applications, then this course will definitely be of value to you. Now, if you're a working professional with no background in computational fluid dynamics or passenger car aerodynamics, right, then yes, this course is great, because this course is a very short course and it helps you get the importance of aerodynamics, and it also tells you how to do a quick aerodynamic analysis study. Now, if you are a professional in EV domain and you are already comfortable with CFD, then the content is going to be extremely basic for you. Okay, so what is covered in this video? In this video, we are going to be looking at the course curriculum. I'm going to be talking about what are the things that you will be learning in this particular course, and that's what you will learn in this video. So the course is going to start with the fundamentals of fluid mechanics, right? At the end of the day, aerodynamics is essentially the study of air and how air interacts with bodies, right? So you need to understand primitive fluid properties, because at the end of the day, all key parameters that aerodynamists use are defined based upon these primitive variables. So you need to understand them. Obviously, I will be talking about why optimizing airflow is a big deal. Most of you already know it. Some of you might not know it. So I want to kind of give you an example for it, which will make the point crystal clear. Then we'll talk about techniques to evaluate aerodynamic performance. And then we'll talk about the need for simulations, and we will perform we'll be looking at two cases. I'll be showing you how to set up one of these simulations, and you will be attempting the second simulation, which is simulating the flow over a two-dimensional passenger car. Okay, the simulations have been kept at a basic level because at the end of the day, the course is fairly simple. Now, in terms of basics of fluid mechanics, the key concepts that we will cover are, the fundamental laws of fluid mechanics, also called as the governing equations in fluid mechanics. We will be learning them, and we will be understanding what physics do these equations capture. When you're talking about deriving the laws of fluid mechanics, they are all derived with the assumption that a continuum exists. So it's very important to understand what continuum means and what Knudsen number means. And then we'll talk about key terms, right? Key fluid terms: pressure, density, temperature, velocity. And we'll talk about key equations. So this is where we'll be doing pen and paper calculations to actually figure out the various aerodynamic forces. And in fact, you will actually see that there are only two types of aerodynamic forces that you need for any type of problem, right? It does not have to be just passenger car aerodynamics. Even if you're designing a jet fighter, right, the fundamental aerodynamic forces, the number of fundamental aerodynamic forces are just two. The only problem is that estimating these two forces becomes very tricky when the application becomes complex, for example, a hypersonic flight, right? So nevertheless, I will be proving it to you that there are only two parameters that you need to understand in order to get into aerodynamics. And then every engineering terminology, every engineering term that is used in aerodynamics is a combination of these two fundamental forces along with some critical geometric properties and flow properties. And then once we have done that, we'll talk about key fluid flow regimes. So here we will primarily talk about inviscid flow and viscous flow, and we'll talk about compressible flows versus incompressible flows, and we'll talk about flow regimes based on speed of sound. Now at the end of the day, for aerodynamic flows, you're primarily going to be looking at viscous flows, meaning the effect of viscosity is taken into account, and you will be taking a look at compressible flows, right? But it's very important to understand what inviscid means. It's very important to understand what incompressible means. And finally, you will learn how speed of sound determines the validity of the compressibility assumption. Okay, I know that at this point, the last point might sound a bit complex, but trust me, it should be fairly straightforward when we get to it. So when it comes to helping you understand why aerodynamics is a big deal, we will be taking a look at the fuel consumption of class 8 trucks in the US. And essentially, I will be calculating the market size for drag reduction strategies. Why is this important? At the end of the day, if you take a look at any engineering company or any engineering services company, they are all catering to a particular market. And it turns out that the market for drag reduction strategies, that is any techniques, right? It could be hardware based techniques or it could be software based techniques which could help reducing drag, has a huge potential, because it turns out that aerodynamics for heavy duty trucks is a $1 billion market, and I'm talking about just class 8 trucks here. If you're wondering what a class 8 truck is, do check out Wikipedia. But in short, class 8 trucks are very heavy. They weigh around 15 tons. Okay, and then when it comes to techniques to evaluate aerodynamic performance, there are two techniques: experimental techniques and computational fluid dynamics. Now there could be one more technique that we could potentially add here, which would be analytical methods. For example, vortex panel methods. There are multiple analytical tools that are available at our disposal. But to be very honest, as of 2020, none of these analytical methods would give you the results that you're looking for, complex geometries under complex flow conditions, right? So that's why I've not mentioned it. But yes, technically, analytical methods, right? Pen and paper calculations are really, really important. And because at the end of the day, these pen and paper calculations are the basis for doing computational fluid dynamics. So, since this is a simulation focused course, I'll be talking about need for simulations. I decided that we don't have to have a separate lecture on it, because I think the point is fairly easy to understand. Let's take a truck that weighs 15 tons, right? If you're basically running experiments on the truck, you need a facility that can actually hold this truck and can perform tests on it. Whereas if you're doing simulations, all you need is the CAD model of that particular truck. So from that aspect, it's fairly easy to see that simulations are going to be really cheap. The thing that you might not understand at this point is that simulations are very fast, and hopefully, when we actually set up the simulation towards the end of the course, you will be able to understand that point. Alright, in terms of projects, there are two projects in this particular course. The first project is a fairly simple project but extremely useful one to learn aerodynamics, which is flow over a cylinder. And then the second project is a flow over a 2D passenger car. The second project is something that you guys are going to be working on your own, right? So which I think is a great thing to do. And you will be given all the details, of course, including geometry and operating conditions, so that you can carry out that study. That being said, I would like to conclude this video. We are really excited about this short course because a lot of students have asked for it. I hope you would consider enrolling into this course and you would learn a lot from it. Thank you so much. Bye.